We talked about Bohr's model of the atom earlier, and now let's look at that once again. So this section of your textbook talks about how the wave nature of matter, that leads to the quantization of energy states and allowed orbits for electrons around an atom. So unlike planets, where planets can orbit basically at any distance around a star, electrons cannot orbit at any distance around an atom. So the wave-like nature of electrons permits only constructive interference for an electron in an orbit around an atom. So if we assume the orbit is circular, that means that the orbit has to have an integer number of wavelengths. So you have to have one complete wavelength for that radius, for that circumference of that orbit, or two complete wavelengths, or three complete wavelengths. So those are allowed. Any non-integer number of wavelengths are not. So the equation that we have to satisfy, the circumference of the orbit, 2 pi times the radius of the orbit, and n is the energy level, again, 1, 2, 3, 4, 5, the principal quantum number, is equal to the principal quantum number times the wavelength. So an integer number of wavelengths has to be equal to that circumference. Or again, r sub n is the radius of the orbit, the wavelength of the electron is lambda. But when we talked earlier, recall that, or de Broglie's formula, the momentum is equal to Planck's constant over the wavelength. I can rearrange this and say the wavelength is Planck's constant over the momentum. Assuming this is not a relativistic electron, and we're going to make that assumption, momentum is just mass times velocity. So I can then recall that momentum is mass times velocity, regular linear momentum. I can plug that in for this p to get this equation. So this here, Planck's constant over the mass of the electron times the velocity, is the wavelength. I'm going to plug that back up over here to get the following equation. So the circumference, 2 pi times the radius, is equal to n, which is that principal quantum number, 1, 2, 3, 4, 5, some integer value, times Planck's constant over the mass of the electron times the velocity. Now I'm going to rearrange the equation a bit. I'm going to bring all the constants onto one side and all the variables onto the other, mainly. So mass of the electron, actually that is a constant, but I'm going to bring it over to the left. The velocity we don't know, I'm going to bring that to the left. The radius can change, I'm going to bring that to the left. Leaving on the right, n, this integer number, Planck's constant over 2 pi. The reason the arrangement is done this way is this is the mass times the velocity, which remember is the momentum, times the distance from the rotation point, the center of the atom, the nucleus, right? This is the radius of the orbit. This is equal to the angular momentum. Angular momentum is linear momentum, times the distance from the rotation axis if the momentum is perpendicular. In this case, it's a circular orbit. So angular momentum is equal to, in this case, the mass of the electron times the electron's velocity times the distance, radius of the orbit. So substituting that in on the left-hand side, the angular momentum has to be equal to n times Planck's constant over 2 pi. This is quantized. Planck's constant is a constant, right? That doesn't change. Pi is a constant. 2 is a number, right? That doesn't change. So the only thing that does change is n. N can be 1, 2, 3, 4, and so on. So the angular momentum has to follow this rule. It can only have allowed momentum. It can only have allowed values, where n can change slightly, and it gives you multiple values to work with, but it can't be anything. So this is why the angular momentum is quantized. That's the assumption that Bohr made, but Bohr did not really understand why that assumption worked. It was an assumption he made when he did his derivation to show that the hydrogen atom worked. His model of the hydrogen atom worked. However, it wasn't until later, when quantum mechanics actually got a little more mature, that it was realized it's the wave nature of matter that is what causes the angular momentum to be quantized. So Bohr kind of stumbled across it a bit. Still did amazing work with understanding the hydrogen atom and his assumption of we just proved the assumption that the angular momentum must be quantized.